students, welcome to Akshat International School online classes. In my previous video, we had discussed about the graphs, if you remember. Okay, there are two types of graphs which we had studied. They are first position time graph, distance time graph, or displacement time graph. This is the first type of graph that I had explained you. Second type of graphs, that is speed time graph or velocity time graph. Now in this lecture we are going to study about the second type of graph, that is speed time or velocity time graph. Fine. Now let's just see that in the previous video we had studied about the distance time or position time graph. Now suppose this axis, which is the y-axis, it represents the position or the distance of an object, and this is our x-axis, which I called as the time axis, if you remember. Okay, because in physics mechanics we used to represent the time on x-axis. In the previous video I had explained you that this is also called time axis. In many questions it is asked that the graph which is parallel to the time axis, what it represents. Okay, like this one, what it represents. It represents that the body is at rest, the object is at rest. How we can say that? See, now as we know, time does not stop for anybody, so time is changing, but the position of the object is same. The position of the object is not changing, so we can say that the position at time, say 1 second, is the same. After 2 seconds, the position is same. After 3 seconds, the position is same. There is no change in the position of the object. So we can say that this graph represents object at rest. Suppose if I ask you that draw a graph for you right now, so how will you represent that? Right now if you are sitting and watching this video, that means you are sitting at a position, you are not changing, but time is changing, your position is not changing. So we'll say that this graph represents your own situation right now. Fine. So this we had discussed in the last video. I was just revising it. Fine. So now, as I said, the next type of graph is the velocity or speed time graph. Fine. Now, what it represents? Let's see. Suppose we have a speed time graph or a velocity time graph. Fine. Now, this, as I said, is the time axis. So it represents time, and here if it represents speed. Fine. Now, this is our x-axis. This is our y-axis. Fine. Now, what if an object is in accelerated motion? Now, what is accelerated motion? If you remember, I explained you that what is the work of accelerator? It changes the speed. Okay, will not say it increases or decreases the speed. It changes the speed because it does both the work. Fine. Now, if the speed is changing, that means we can say this axis I have different speeds. So let me mark these speeds. Say this is 5 meter per second. Say this is 10 meter per second. Say this is 15 meter per second. Okay. Now, suppose object, when it started, after its 5 seconds, the speed is 5 meter per second. After 10 seconds, say the speed is 10 meter per second. After 15 seconds, say the speed is 15 meter per second. Now, if I want to plot it, so you have learned in class 8 the coordinate geometry. If I want to mark these points, I can mark these points like this. Okay. Similarly here also, and when I join these lines, I get a straight line which is inclined with time axis. Now, in exams they are not going to give like this, but simply they will ask you that this is a VT graph, say speed time graph. What does it shows? If we have a straight line inclined to time axis, don't get confused. Because straight line is this also. This is a straight line parallel to time axis. You have to see the words. Fine. Now this is straight line inclined with time axis, VT graph. What this graph shows? So this graph shows that object is uniformly accelerated. Means the speed is uniformly changing. Fine. Like in 5 seconds the speed is 5 meter per second. In next 5 seconds the speed is 10 meter per second. In next 5 seconds the speed is 15 meter per second. Fine. So this graph shows object M or object is uniformly accelerated. Fine. Now next in this type of graph we have, see, again, now if the object is not uniformly accelerated, which usually happens, okay, when we drive with, because we have different speeds at different time, we are not uniformly accelerated. So suppose if you are going to come to school by your bus, then the bus is not uniformly accelerated. Fine. So how we are going to represent it? So the representation of that graph will be a curve. Why? Because see, in this one, at this time, the speed is this one. Now, if I take equal interval, and if I take, suppose say this is 5 seconds and this is say 10 seconds. Now in 10 seconds, the speed is not uniformly changed. Fine. Similarly, if I say next 5 seconds, say 15 seconds. Now, in this one, all of the sudden, the speed is this. So this portion is not equal to this one. That means this is non-uniform graph. Object is accelerating but non-uniformly. Fine. So this is the graph which represent acceleration. This is a VT graph, that is speed time graph, but it shows non-uniform acceleration. Okay. Now what if we have a graph which is parallel to time axis, but it is not a position time or a distance time graph, but it is, suppose, a speed time or a velocity time graph, in which if I have a graph which is parallel to time axis. Now what it represents? See, as you see from the graph that time is changing, but the object is not changing its velocity. Fine. At this time, the velocity of the object is this one. Say, now if time is, say again I take the same values, say 5, 10 and 15. Here also. Now say this is 5, this is 10, say this is 15. Now, at 5 seconds, the speed of the object is 10 meter per second. Next, after 5 seconds, the speed is again 10 meter per second. 15, again the speed is 10 meter per second. So what does this graph represent? It shows two things, but they both are same. Two things, that is, the speed of the object is constant. If you're going to write this is also your answer. Or we say the acceleration is 0. The acceleration of the object is 0. Okay, this is that condition in which you are not changing the speed. Means neither you are accelerating nor you are deaccelerating. You are moving with a constant speed. Fine. So in exam, if it comes that in a VT graph, say this is the VT graph. Okay. In this one, what this graph represents? Okay. It is a 1 mark question. So just we have to write that the speed of the object is constant. This is also correct. Or you can write that acceleration of the object is 0. Most of the students get confused, and if it is asked that what this VT graph shows, they used to write object at rest. No. For object at rest, we had studied it should be a distance time graph or a position time graph. The object is not changing its position because this axis represents the position of the object. Okay, here this axis is representing the velocity or the speed of the object. Fine. So we have to be very careful that what is given here on y-axis, because it is yes for sure that this will be time, as I had mentioned. because this is our time axis. Fine. But here we have to see at what is given. If it is given distance, position or displacement, they are one and the same in particular graphs. Fine. So they will represent object at rest. Here we can write object at rest. But here object is moving with constant speed. It's not at rest. Okay? Here object is not accelerating. The object is not accelerating. They are not changing the speed. So this is at constant velocity. Object is moving with constant velocity or its acceleration is 0. So this is another type of graph, VT graph, which is asked. Fine. Let's move and see the another graph, VT graph only. In this also, it is asked that suppose we have a VT graph, and in this one, they are drawing like this. Now this graph, what this graph represents? Now you can see, if you know how to read the graph, you see at this point, the speed of the object is this one. Whatever. At this point, the speed of the object is this one. At different time. Okay? Now at this point, the speed is this. So what is happening? The object is decreasing the speed. Okay? The object is decreasing the speed. See, time will increase. Okay? Because time is not changing. Fine? Time is not constant. It will change and it will move forward. But here we'll see the speed is decreasing. And finally, at this point, that is at t equal to 0, objects comes to rest. That means this graph shows retardation or deceleration. This graph shows retardation. Object is retarding, means its speed is decreasing. And finally, it comes to 0. Now, because it is a straight line, we'll say that this is uniform retardation. If suppose in the same VT graph, if it is a curve, but that curve is coming down, it shows retardation but non-uniform retardation. This is also called deceleration, negative acceleration. We can say negative acceleration also. If you remember the formula of acceleration, a equal to v minus u by t. Now why it is called negative acceleration? So let's prove it. Okay, now suppose this is the speed of the object, say 20 meter per second. This is the speed of the object, say 15 meter per second. Okay, now this is from 0 to 5. Okay, now putting the values over there to find out the acceleration. Say this is the initial velocity u, because initially it was 20 meter per second, and this is the final velocity, say v, and this is the time, 5 seconds. So putting the values, we'll get a equals to, this is the final velocity, say 15, this is the initial velocity, say 20, upon this is 5. So what is the value here? Here it is minus 5 by 5, or I can say minus 1 meter per second square. So I get a negative value. So this is also called negative acceleration. So don't get confused with the terminologies. Fine, whether it is retardation or deceleration or negative acceleration, आप जो लिखेंगे you have to write this graph as the uniform retardation or uniform deceleration, or uniformly object is giving the negative acceleration. So this is the another type of graph which is asked. Okay, I hope you got this point.